Okay, so this is the Unit 1 homework problem number 10. Okay, so here we have basically a car, and it's traveling at 90 kilometers per hour. And it said in a controlled test, it takes a driver 0.32 seconds to hit the brakes in a crisis when unimpaired. But if they're drunk and impaired, it takes them 1 second. It takes them 1 second to process the fact that they need to stop and to hit the brakes. Okay, and so the question is, how much further does the car travel before coming to the stop when the person is drunk compared to when they're sober? Okay, so let's start by thinking about how we're going to solve this problem. Okay, so in both problems, they're going to hit the brakes, and we're going to assume that they slam on the brakes, and that the delta x, or the displacement after they slam on the brakes is going to be the same in both cases. Okay, is the same in both cases. Okay, because they're starting at 90 kilometers per hour. Okay, they have some sort of reaction time. Okay, so this delta x for 0.32 seconds versus if we have here, well, this is sober. Okay, and this is our drunk driver here. Terribly drawn car. But the delta x is going to be larger for the drunk driver. Okay, because the time is longer. Okay, so they take 1 second. So they're going to travel a longer distance. But let's say once they slam on the brakes, we're assuming that delta x of braking, okay, is going to be the same for both. Let me see if I can just copy and paste. I don't know if I can. I'll try to draw it exactly the same length here. Okay, so this delta x of braking is going to be the same length as when they're sober. Okay, so what we get is we get a difference here. So our only difference is this distance here that they travel in the extra 0.68 seconds. Okay, so if we take 1 second minus 0.32 seconds, we get 0.68 seconds of extra time traveling at 90 kilometers per hour. Okay, so if you think about the problem, kind of draw out what's going on, really all we need to find is how far the drunk driver travels in those 0.68 extra seconds that it takes them to slam on the brakes. Okay, if they're going at 90 kilometers per hour, we probably want to get that to meters per second because it'll probably be on the order of meters that they travel in 0.68 seconds. So if we take 90 kilometers per hour, okay, so they travel 90 kilometers, I don't know why, in 1 hour. We use our knowledge of how to convert things. 1 hour is 3,600 seconds. And we got 1,000 meters in 1 kilometer. Okay, multiplying the top and then multiplying the bottom out. We get 9 times 10 to the 4 over 3.6 times 10 to the 3. And we end up with 25 meters per second. Okay, as the speed in meters per second, which is equivalent, right, to 90 kilometers per hour. We have our units here in seconds that we know, so we wanted to get to meters per second because it's likely going to travel meters. So we already did that conversion, and we need to have our speed or velocity in seconds because our time that we know is in seconds. Okay, so if we take we know that our velocity is our displacement over time. So if we take v times t, that will give us that displacement. So all we need to actually do for this problem is we take 25 times 0.68 seconds. Okay, and our meters per second cancels out, the seconds cancel out, and we're left with just meters. So we get 17.0 meters as our answer. That's the extra distance right here that is traveled by the drunk driver. Okay, we don't have to know the total distance traveled. I mean, we don't know anything about the acceleration when the brakes are hit, or the deceleration of the car. So we just want to know the difference, which we're able to find because we know that drunk driver is just traveling at 90 kilometers per hour for an extra 0.68 seconds. Okay, so hopefully that was helpful. Here, I'll get it so the whole problem is on the screen. So hopefully that helped you understand problem number 10 on the homework.